have saw using Cramer's rule solving a linear equations. Now in exercise 1.5 we are going to see the Gauss elimination method, which one is very easiest exercise which we can derive using the rank method, that is row elimination method, which we saw on exercise 1.2. the method which we done on here we are going to use here, Gauss elimination method. Very easy exercise. It contains nearly the first sum contains 2 subdivisions, second sum, third sum, fourth sum are word problems. Very easy sum, and you can expect 5 mark from this exercise. So we will enter inside the exercise 1.5. Exercise 1.5. See, once again solve the following system of linear equations. They given the linear equations. So in exercise 1.3 we saw linear equation using matrix inversion method. In exercise 1.4 we have solved linear equation using Cramer's rule. In exercise 1.5 we are going to solve linear equation using Gaussian elimination method. In this first sum it contains 2 subdivisions, very easy sum only. Then second sum and third sum, fourth sum are word problem sums. If we going to do these 2 sums understandingly and neatly, then you can solve second sum, third sum, fourth sum also very easily. So we enter inside the first sum. Exercise 1.5. The first sum, solve the following system of linear equations by Gaussian elimination method. They given the first subdivision 2x minus 2y plus 3z is equal to 2, x plus 2y minus z is equal to 3, 3x minus y plus 2z is equal to 1. They given 3 linear equations. So solution, the above equation can be written in the form of nothing but the form we written in the matrix inversion method. The same form we need to write here also. What is the form we use in matrix inversion method? The coefficient of x, coefficient of y and coefficient of z, the same one. 2, 1 and 3, 2, 1 and 3, minus 2, 2, minus 1, minus 2, 2 and minus 1. Finally 3, minus 1 and 2, 3, minus 1 and 2. So find the variable, the x, y, z is equal to the constant 2, 3, 1. The constant is nothing but 2, 3, 1. So this one is called A matrix, this is called a caps X matrix, and this one is called caps B matrix. Where you know what is A matrix? This is A matrix. Listen carefully. This is A matrix. This is B matrix. Now we are going to join A matrix and B matrix. This name is called augmented matrix. We are going to join A matrix and B matrix. This is A matrix and B matrix. We are going to join A matrix and B matrix. This name we call as augmented matrix. Augmented matrix. By joining A matrix and B matrix, this is called augmented matrix. The augmented matrix is the augmented matrix. The augmented matrices we can write A comma B, because we are going to join A matrix and B matrix. A matrix and B matrix is equal to, so what is A matrix here? 2, minus 2, 3, 1, 2, minus 1, 3, minus 1 and 2. We have written A matrix. Next we need to write B matrix. This is B matrix. 2, 3 and 1. What is the augmented matrix? Augmented matrix nothing but joining A matrix and B matrix in one matrix. joining A matrix and B matrix in one matrix. I join A matrix and B matrix in one matrix. You can put bracket this type of no problem, because I use this type of bracket, so I can use this type of bracket in both sides, no problem. You can do any type of brackets. You can use this type or you can use this type also, no problem. So this is joining of two matrix. Now I have told always this A1 if always going to be 1, it will be very easy. Keep it. So first similar. So what I am going to do, this I am going to, this is nothing but R1, this is R2, R3. This is A11. If A11 is always 1, it will be very easy. So I need to interchange R1 in place of R2 and R2 in place of R1. Nothing but R1 will move towards R2 and R2 will move towards R1. So 1, 2, minus 1, 3. This is R2. This R2 comes towards R1. 1, 2, minus 1, 3. This R1 comes to R2. 2, minus 2, 3 and 2. And R3 remains as it is. So write 3, minus 1, 2 and 1. R3 remains as it is. So no problem in this sum. So we have no problem. So next what is the main thing? The main thing is nothing but we need to change this A21 and A31 is 0 with the help of R1. So there is no change in R1. Write R1 as it is. 1, 2, minus 1, 3. This is 2. If I am going to multiply R1 with minus 2, R1 with minus 2, 2 minus 2 becomes 0. So I am going to change R2. R2 tends to R2 minus 2 R1. The same here 3, here should be minus 3. So R1 should be multiplied with R3. So R3 tends to R3 minus 3 R1 minus 3 R1. Now I will write this rough column here. So lack of space, I will write the rough column here itself. So here there is no space, so I write rough column here. R2 tends to, first write R2. What is R2 here? 2 minus 2, 3, 2. 3, 2. Minus 2 into R1. This R1 is multiplied with minus 2. 1 into minus 2, minus 2. 2 into minus 2, minus 4. This minus into minus plus. 2 into 1, 2. Minus 2 into 3, minus 6. So what is the answer is going to be? 0. This will be minus 6. 3 plus 2, 6. 2 minus 6 is minus 4. The answer is going to be 0. 3 plus 2, 5. 0, minus 6, 5 and minus 4. Next write R3 tends to, write R3 as it is. 3 minus 1, 3, minus 1, 2 and 1. Multiply R1 into minus 3. 1 into minus 3 is minus 3. 2 into minus 3, minus 6. Minus into minus plus. 1 into 3, 3. Minus into minus plus. 4 3s are 12. 0, minus 1, minus 6, which gives us minus 7. 2 plus 3 gives us 5. 1 plus 3 into 3, minus 9. This is minus 9. So minus 9 plus 1, which gives us minus 8. So 0, minus 7, 5 and minus 8. So we have got 0 and 0. Next we need to convert this one as 0. We need to convert this one as 0. The main thing, this one is 0. If I need to convert this one as 0, the main logic is missing here, because this is minus 6, this is minus 1. This is a prime number, somewhat confused. So there is change only on, R3. There is no change in R1, R2. Write R1 and R2 as it is. R1 and R2 write as it is. 1, 2, minus 1, 3, 0, minus 6, 5, minus 4. There is change only on R3. How we can change R3? R3 tends to. So I need to get 0 here. For getting 0 here, I need to multiply this one as 7. I need to multiply this one as 6, because 6 7s are 42, 7 6 are 42. So no problem. Both are getting 42. But the main aim is here minus is present. So this one I can multiply with minus 7 and this one I can multiply with 6, because minus 7 into 6 is minus 42. Minus into minus plus, 6 7s are plus 42. This will become plus 42. This will become minus 42. So I will get a 0 here. So first write R3 tends to R3. What R3? 6 R3. 6 R3 minus 7R2 minus 7R2. 6R3 minus 7R2. So 6R3 I will do here rough column. I will do rough column here. Okay. So 6 into R3. So 0 into 6 is nothing but 0. Minus 7 into 6 is nothing but minus 42. 5 6 are 30. Minus 8 into 6. 8 6 are 48, nothing but minus 48. 8 6 are 48 is nothing but minus 48. So minus 7 into R2. So this is R2. 0 into minus 7, 0. Minus into minus plus. 6 7s are plus 42. Next. 5 into minus 7, minus 35. Minus into minus plus. 4 7s are 28. 4 7s are 28. So what is the answer going to be? 0. 0. 30 minus 30 minus 35 minus 5. 0. 4 20. What 20? Minus 20. So I am going to write here. 0. 0. Minus 5 and minus 20. So I will write the step once again here. So I am continuing the sum here, next page. So I written the before step here. So this is called echelon form. See, 0 0 0. Number of zeros in the last row is greater than the previous row. This is in the form of echelon. This is in the form of echelon form. Echelon form. Now I am going to use method of back substitution. Using method of back substitution. Back substitution. What is meant by method of back substitution? I will tell you. You know, this is x coefficient, y coefficient, z coefficient, and this one is called constant. You know, this one is called constant. We are taking the first step. Sorry, this is called B matrix. We are taking B matrix. The x coefficient, y coefficient, z coefficient. These alone enough. We will take this one as a constant. The method of back substitution is nothing but we are going to move in this matrix from backwards. For example, this is minus 5 into z. Minus 5z is equal to minus 20. Minus 5z is equal to minus 20. So this minus we cancel. Z is equal to 20 by 4 will got us answer as z is equal to 20 by 5. We get answer as z is equal to 4. So this is the first one. Now using back substitution. After doing this, I am going to move another back. This is minus 6y, right? Minus 6y plus 5z is equal to minus 4. So minus 6y plus 5. What is z? 4 is equal to minus 4. Minus 6y, 5 4s are 20 is equal to minus 4. 20 comes this side. So it becomes minus 6y minus 4 minus 20. Minus 6y is equal to minus 24. Minus cancel. Y is equal to 24 by 6. That 24 by 6 is nothing but the one second answer is nothing but 4. Y is equal to 4. Use one second method of back substitution. This is 1 into x is x. 2 into y is 2y. Z into minus 1 is minus z is equal to 3. So x we need to find x plus 2. Y is also 4. Z is also 4 is equal to 3. X 2 4s are 8. Minus 4 is equal to 3. X 8 plus 8 minus 4. 8 minus 4 is nothing but 4 is equal to 3. X is equal to 3 minus 4. X is equal to minus 1. We have got x is equal to minus 1. Therefore, solution x comma y comma z is equal to minus 1 comma 4 comma 4. If you want to check this answer, we can apply this answer in any one of the equation. For example, if I am going to if I am going to get, I am going to take one equation, that is second equation, x plus 2y minus z is equal to 3. So apply this is x, y, z. X is nothing but minus 1, y is 4. Therefore, 2 4s are 8. Z is 4. So minus 4 is equal to 3. 8 minus 1, nothing but 8 minus 5 equal to 3. 8 minus 5 is 3 equal to 3. So the answer we got is correct answer. First sum, second subdivision. Solve the following system of linear equation using Gaussian elimination method solution. The above equation can be written in the form of matrix. First x coefficient, y coefficient, z coefficient. X coefficient is 2, 3, minus 1. 2, 3, minus 1. Next 4, 8 and 1. 4, 8, 1. Next finally 6, 5, 2. 6, 5, 2. This one is x, y, z is equal to NADAR'S constant 22, 27 and 2. So this will be caps A, caps X is equal to caps B. So this is cap C. Next we need to join A matrix and B matrix. The joining of A matrix and B matrix we named as augmented matrix. The augmented matrix. Joining of A matrix and B matrix is A, B is equal to A matrix nothing but 2, 4, 6, 3, 8, 5, minus 1, 1 and 2, 22, 27 and 2, 22, 27 and 2. This one is R1, R2, R3. In R1, the first element should A11, the first element should be 1 but it's 2. So I am going to divide 2, 4, 6, 22. Totally this R1 can be divided by 2. That is nothing can be able divisible is not possible. No element divisible is possible, but this is one is possible, divide by 2. So R1 tends to R1 by 2. So similar. So there is change only on R1. So leave R2. So leave R1 as it is and write R2 and R3. First write R2. R2 is 3, 8, 5, 27. R3 is minus 1, 1, 2 and 2. R1 tends to R1 divide by 2. R1 tends to R1 divide by 2. R1 divide by 2 is nothing but 2 by 2 is 1 SE. 4 by 2. 4 by 2 is nothing but 2. 6 by 2 is 3. 22 by 2 is 11. So nothing but 1, 2, 3 and 11. Now see we have got 1 here. So next I want to change R2 and R3. How am I going to change? I want to make this one as 0 and this one is 0. There is no change in R1. Write R1 as it is 1, 2, 3, 11. How I will change R2? R2 tends to R2. This one I should multiply with minus 3. Minus 3 R1. So write R2 as it is. First write R2 as it is. What is R2 here? R2 is nothing but 3, 8, 5 and 27. R2 minus 3 R1. 1 into minus 3 is minus 3. 2 into minus 3 is minus 6. 3 into minus 3 is minus 9. 11 into minus 3 is minus 33. So 3 minus 3 we get a 0. 0. 8 minus 6 we get a 2. 5 minus 9 we get as minus 4. 27 minus 33 which gives us minus 6. So 0, 2, minus 4 and minus 6. Next R3 tends to, this is plus 1, this is minus 1. Minus 1 plus 1 which gives us 0. So R3 tends to R3 plus R1. I need to make addition. Minus 1 plus 1, 0. Addition only. R3 plus R1. 1 plus 2, 3. 2 plus 3, 5. 2 plus 11, 13. 2 plus 11 is nothing but 13. So next if we are going to see 2 minus 4 minus 6. This R2 I can divide it by 2. So it becomes very easy to make substitution. So there is no change in R1 and R3. Write R1, R3 as it is 1, 2, 3 and 11. R3, write R3 as it is 0, 3, 5 and 13. So R2 tends to R2 divided by 2. So 0 by 2 is 0, 2 by 2 is 1, minus 4 by 2 is minus 2, next minus 6 by 2 is minus 3. So we have got this one. The final answer we want to get this one as make the 0. If I want to make this one as 0, I need to get out of R2. R2, there is only change in R3. There is no change in R1 and R2. So write R1 and R2 as it is. 1, 2, 3, 11, 0, 1, minus 2, minus 3. R3 tends to. So this is 3. I want to multiply this one as minus 3. R3 tends to R3 minus 3 R2. Minus 3 R2. So first write R3 as it is. 0, 3, 5, 13. Multiply R2 with minus 3. R2 minus 3. Minus 3 into 0, 0. Minus 3 into 1, minus 3. Minus into minus plus, 3 2s are 6. Minus into minus plus, 3 3s are 9. So what is the answer? 0 plus 0, 0. 3 minus 3, 0. 5 plus 6, 11. 13 plus 9 is nothing but 22. 0, 0, 11 and 22. So we have got an echelon form. Therefore above matrix this is in the form of echelon. This is in the form of echelon. So what method we can use? I am going to use method of back of substitution. Method of back substitution. Using method of back substitution. Method of back substitution. This is x coefficient, y coefficient, z. This is nothing but a constant. This is nothing but matrix B. So back substitution means 11 into z is nothing but 11 z is equal to 22. You know z is equal to 22 by 11. We get answer as 2. We get answer as 2. So finally this is 1 into y is y, minus 2 into z is minus 2 z is equal to minus 3. So what are you going to get? Nothing but 1 into z is 1 into y is y, minus 2 into z is 2z is equal to minus 3. So y minus 2, z we have found nothing but 2, minus 3, y minus 4 is equal to minus 3, minus 4 from this side, minus 3 plus 4, y is equal to 1. So finally we need to do is nothing but I need to do this one. 1 into x is x, 2 into y is 2y, 3 into z is 3z is equal to 11. So easy to do. 1 into x is x plus 2y plus 3z is equal to 11. I need to find the value of x. X plus y answer is 1, z answer is 2 is equal to 11. X 2 into 1 is 2, 3 2s are 6 is equal to 11. X plus 8 is equal to 11. Now finally x is equal to 11 minus 8. Therefore x is equal to 3. The final answer we can write as solution. Solution x comma y comma z is equal to 3 comma 1 comma 2. If you want, you can check this answer by applying this value of x, y, z in any of the 3 equations it's given in the question. Exercise 1.5, second sum. If a x square plus bx plus c, this is one of the quadratic equation, a x square plus bx plus c is divided by x plus 3. This equation is divided by x plus 3. The remainder is 21. Listen carefully. If this quadratic equation is divided by x plus 3, we get remainder as 21. The same equation is divided by x minus 5, we get remainder as 61. The same equation is divided by x minus 1, we get remainder as 9. So we are using the remainder theorem which we studied in 9th standard. So what we want to find? We need to find a, b and c. We need to find a, b and c. So first we are going to assume let f of x is equal to a x square plus bx plus c. f of x is equal to ax square plus bx plus c. First we are going to divide by x plus 3. We are going to divide by x plus 3. So how I can write x plus 3 is equal to 0. So therefore x is equal to minus 3. So apply in place of x we need to apply minus 3. In place of x apply minus 3. So f of minus 3 is equal to a into minus 3 the whole square plus b into minus 3 plus c. In place of x apply minus 3. In place of x apply minus 3. Finally the constant. So since if we going to divide this ax square plus bx plus c divided by x plus 3, we get remainder as 21. So f of minus 3 is nothing but 21. So 21 is equal to minus 3 the whole square is 9. So we can write as 9 into a plus into minus minus 3 into b is 3b. Final answer is C. So 21 is equal to 9a minus 3b plus c. Finally we will arrange the equation. Still now we will keep it as it is. So once again we are going to divide this equation divided by x minus 5. So x minus 5 is equal to 0. We can write x is equal to 5. So apply x is equal to 5 in this equation. So f of minus 5, wherever x is present apply minus 5. F of not minus 5 plus 5, sorry, f of 5 is equal to a into 5 the whole square plus b into 5 plus c. F of 5, this f of 5 is nothing but the remainder. What is the remainder here? 61 is equal to 5 the whole square is 25a. 5 into b is nothing but 5b. Finally the constant c. 61 is equal to 25a plus 5b plus c is equal to 61. And lastly we are going to divide this equation using x minus 1. Since x minus 1 equals 0, x is equal to 1. So apply x is equal to 1. Wherever x is present apply 1. So f of 1 is equal to a into 1 the whole square plus b into 1 plus c. F of 1. What is the remainder we have got? We have got the remainder as 9. F of 1 is equal to 9. 9 is equal to 1 the whole square 1. 1 into a is a. B into 1 is b. B plus c. 9 is equal to a plus b plus c. So we will arrange these three equations and write in another page. So we have formed three equations. These three equations, the above equation can be written in the form of the above equation can be written in the form of what is the how we can write in the matrix inversion method? Nothing but a coefficient, b coefficient, c coefficient. So a coefficient is 9, 25, this is 1, minus 3, 5, minus 3, 5 and 1, minus 3, 5 and 1. Finally 1, 1, 1, 1, 1, 1. Next, the three variables a, b, c, three unknown variables is equal to constant 21, 61 and 9. So this one is cap 6, cap ca, this one is cap 6 is equal to b. This is A matrix, this is B matrix. The combination of A matrix and B matrix, nothing but augmented matrix. The augmented matrix is, so combine A matrix and B matrix is equal to A matrix 9, minus 3, 1, 25, 5, 1, 1, 1, 1. This is A matrix. Combine B matrix 21, 61 and 9. So this one is R1, R2 and R3. You know in R1 and R2 and R3, this A1 should be always 1. So we will take R1 will move to R3 and R3 will move to R1 so that we can get the answer. So there is no change in R2. There is no change in R2. There is change in R1 will move to R3 and R3 will move to R1. So 1, this R3 will move to R1. 1, 1, 1, 9. There is no change in R2. So 25, 5, 1, 61. That is next R1 will move towards R3, no. So 9, minus 3, 1 and 21. So next what we are going to do? So we need to make this one as 0. How we make these two one as 0? So there is no change in R1. Write R1 as it is 1, 1, 1 and 9. There is change in R2. There is change in R3. R2 tends to R2. This is 25. This should be multiplied by minus 25. Minus 25 R1. So write R2 first. R2 25, 5, 1, 61. R1 should be multiplied by minus 25. 1 into minus 25 is minus 25. 1 into minus 25 is minus 25. 1 into minus 25 is minus 25. 9 into minus 25 is nothing but minus 225. Minus 225. So minus 25 minus plus 25 is nothing but 0. 5 minus 25 is nothing but minus 20. 1 minus 25 is nothing but minus 24. 61 minus 225 is nothing but minus 164. So write 0, minus 20, minus 24 and minus 164. Next, there is change in R3. R3 tends to, this is 9. I need to multiply this one as into minus 9. R3 tends to R3 minus 9 R1. First write R3, 9 minus 3, 121. Multiply with minus 9. 1 into minus 9 minus 9. 1 into minus 9 is minus 9. 1 into minus 9 is minus 9. 9 into minus 9 is minus 81. So 0. Minus 3 minus 9 is minus 12. 1 minus 9 is minus 8. Minus 81 minus 2 minus 81 minus 21, which gives us minus 60. So write 0, minus 12, minus 8, minus 60. So matrix. So if you are going to see, this R2 and R3 can be divisible by 4. So there is no change in R1. So 1, 1, 1, 9. There is change in R2. R2 tends to R2 divided by minus 4 is common. So divide by minus 4. 0 by minus 4 is 0. Minus into minus cancel. 24 and cancel, which gets us 5. Minus and minus cancel. 24 by 4 is nothing but 6. Minus and minus cancel. 164 by 4 is nothing but plus 41. The same R3 tends to R3 divided by minus 4. So 0 divided by minus 4 is nothing but 0. Next, minus minus gets cancelled. 12 by 4 is 3. Minus minus gets cancelled. 8 by 4 is 2. Minus minus cancel. 60 by 4 is nothing but 15. So I want to make this element as 0. There is no change in R1 and R2. So write R1 and R2 as it is. R1 and R2 as it is. 1, 1, 1 and 9, 0, 5, 6 and 41. There is change only in R3. R3 tends to R3. See here, this is 5, this is 3. So this 5 R3, this will 5 R3, this will be 3 R1. R3 nothing but 5 R3, 5 R3 minus 3 R1. So R3 should be multiplied with 5. 0 into 0, 0. 3 5s are 15. 5 2s are 10. 15 5s are 75. Next, minus 3. R1 should be multiplied with minus 3. 0 into minus 3, 0. 5 into minus 3, minus 15. Sorry, R2. Because R3 minus R2. 0 into 3, 0. 5 into minus 3, minus 15. 6 into minus 3 is minus 18. 41 into minus 3. 3 into 1 is 3. 4 3s are 12. Minus 123. So 0, 0, 0. 15 minus 15 is 0. 10 minus 18 is minus 8. 75 minus 123 is nothing but minus 48. 0, 0, minus 8, minus 48. So see, echelon form. This is in the form of echelon. Now I need to use method of back substitution. So I will write this matrix form in another page using method of back substitution. This is A coefficient, B coefficient, C. Minus 8 into C, which gives us minus 8C is equal to minus 48. Minus minus gets cancelled. C is equal to 48 by 8. C is equal to 6 because 8 6 are 48. Answer C is equal to 6. Next, this is 5E plus 6C is equal to 41. 5E plus C is 6, no, 6 6 are 36 is equal to 41. So 41, 36 comes there, which becomes minus 36 is equal to 5B, and 5B is equal to 41 minus 30, which gives us 5. B is equal to 5 by 5. B is equal to 5 by 5, which gets answer as 1. Next, the final step is nothing but last one. 1 into A is A, 1 into B is B, 1 into C is C is equal to 9. A we need to find. B answer is 1. C answer is 6 is equal to 9. A plus 7 is equal to 9. A is equal to 9 minus 7. A is equal to 2. So we have found A, B and C. So we can apply this A and BC in this quadratic equation also, no problem. Therefore, f of x is equal to ax square plus bx plus c. What is A answer? 2x square. B is 1, no. 1 into B is B. 1 into B, 1 into x is x, and c is nothing but 6. So f of x is equal to 2x square plus x plus 6. But the main thing they are asking A, B and C. Therefore, A is equal to 2, B is equal to 1, C is equal to 6. This is the main solution for this sum, because this is our question. This only we need to find.